In this video, we're going to focus on just manipulating multivariable equations. We've been working with equations containing more than one variable, and we're going to look at a few here that actually involve conversions or common formulas that we're going to rewrite. But oftentimes, as we've seen, it's beneficial to be able to isolate one of the knowns or unknowns in the equation and then get everything else on the other side. So that's what we're going to be doing in these three, starting with the first one here. It says the formula for the perimeter of a rectangle is P equals, this is 2L. Okay, I'll write it this way, 2L plus 2W. This is our formula for the perimeter of a rectangle. Okay, so we have our perimeter. We'll call this the width, and we'll call this the length. But what if I wanted to solve for the width in terms of the perimeter and the length? That is, what if I already knew the perimeter and I already knew the length? We could plug those things in and get W by itself, but what I would like to kind of posit here is this. We could get W by itself without even knowing what P and L equal. We can leave them alone and more general, okay? So in this instance, what we're going to do is this. We're going to say, well, P is 2W plus 2L, okay? And we want to get W by itself. So the first thing we want to do, it's kind of like solving an equation, is this: simplify both sides if we can. Now, I don't notice anything that we can do here necessarily, but also this combine like terms. And I also notice that I don't have any other W's, which is the thing I'm solving for. So since I don't have to simplify, we move on to, do I have W's on both sides? And again, I don't have W's on both sides. So this is nice, because now what we want to do is we want to identify every single thing that is on the same side as W, but that is not W. And you'll notice that I just rewrote this equation. What if this equation said this? How would you solve for W? I think that the rightful course of action would be to get rid of this 2 and then divide by this 2 here. And we're going to treat this the exact same way. So what I'm looking at here is this. I just want to point this out, that this 2L that's on the right-hand side, we're going to undo our addition and subtraction first. So get rid of the 2L. But those are glued together. So in order to get rid of it, to get rid of a positive 2L, we have to subtract 2L from both sides. Okay? And the thing that's going to be true is this, essentially. Those cancel out. And we're left with 2 W's on the right, but these are not like terms on the left. So we're just going to leave this as P minus 2 lengths. So in other words, it is always true, by the way, that when you have a rectangle, 2 of these widths always equal the entire perimeter minus 2 of the lengths. If you think about it, if you were to take the whole perimeter, which is this distance around the outside, and it says, hey, 2 of these widths, these things right here, are equal to what you get when you add all these things up and then take out these right here. Those would be left over. And that makes sense. But again, let's go ahead and finish solving for this. So we want to get rid of this 2, so we're going to divide by 2 here. And what we end up with is this. Essentially, the width is equal to the perimeter minus 2 lengths split in half. And it is entirely okay, by the way, since we have a monomial divisor, to split all of the terms in the numerator up over that divisor. So if we wanted to, we could say, well, this is a 1 here. We could say this is 1/2 P minus, now 2 divided by 2 is 1, so we'd say L, and this equals W. But both of these statements would mean the same thing. So kind of burying a couple other ones here really quickly, we want to solve, say, this formula here. The area for a triangle is 1/2 base times height. We want to solve for the H. So here we go. We say area is 1/2 times the base times the height. So we want to solve for H here. So again, simplify both sides, not necessary. Okay? Are all the H's on one side? All the H's are on one side. So now we can get it by itself. Let's identify everything else that's in the way. So I notice that I have a B here. I also have a 1/2. I also notice that these are both being multiplied, okay, by the right side. So in order to, say, get rid of the B, we could divide both sides by B. This is an entirely possible thing to do. It would cancel this out, and we're left with this. 1/2 of H is equal to A over B, capital A over B. Okay, don't write it this way, by the way. Don't write your fractions that way, because when you get to calculus, you're just going to confuse yourself. So we have capital A over lowercase b. The next thing we need to do is get rid of multiply by 1/2. Now we can divide by 1/2, but I do want to point this out. When you divide by a fraction, you end up just multiplying by the reciprocal anyways. Oh, and by the way, anything times its reciprocal is just 1. So we get 1 times H, or just H. Suppose we get to write it this way. On the left side, we need to take this times 2 over 1. So we get this. 2 areas divided by the base always equals the height if you're talking about a triangle. And last but not least, my favorite, talk about medical conversions, okay? We want to solve for C here. So we've got Fahrenheit equals 9/5 Celsius plus 32 degrees. And what this does is it converts, degrees in Celsius to Fahrenheit. Okay, so let's say I want to get Celsius from Fahrenheit. Maybe I should get C by itself. So the first thing to go, just like any other equation, you simplify, get all your C's on one side. We do have that on one side. So now I'm identifying things on the same side that need to go. And again, we'll always undo our addition subtraction first. So I end up with this. In general, we say our 32s are gone. I've got 9/5 of Celsius temperature equal to F minus 32. We're just going to leave this alone. Actually, I hope you notice I put this in parentheses because it represents one full number, and what I'm about to do is this. I'm about to multiply the right-hand side to get rid of this fraction by the reciprocal of itself. So I get this. Just 1C is equal to 5/9 F minus 32. And that's how you would convert, or at least isolate some variables for multivariable equations and have them come in handy. Cheers.